Dear children, here we are going to learn trigonometric identities. What is by an identity? An equation is called an identity when it is true for all values of the variables involved. An equation is called an identity when it is true for all values of the variables involved. Suppose an example, a plus b the whole square is equal to a square plus 2ab plus b square. It is an identity. This identity we have studied earlier. A plus b the whole square is equal to a square plus 2ab plus b square. Any value you substitute in place of a and b. Suppose an example, 2a is equal to 2, b is equal to 3. Then 2 plus 3 the whole square is equal to a is equal to 2, a square 2 square plus 2 into a is equal to 2 into b is equal to 3 plus b square, that is 3 square, is equal to 2 plus 3, that is 5, 5 square is equal to 2 square, 2 2s are 4 plus 2 2s are 4, 4 3s are 12 plus 3 square, 3 3s are 9. 5 square, 5 5s are 25 is equal to 12 plus 9, 21, 21 plus 4, 25. See, both sides it is equal. It is true for all the values of a and b. It is this equation is true for all the values of a and b. Any value you substitute in place of a and b, it will be true. That means both sides will get equal. That is why this equation is called an identity. That is called an identity. So, what is by an identity? An equation is called an identity when it is true for all values of the variables involved. When it is true for all values of the variables involved. That means any value you substitute in the variables, then both sides will get equal. That is true. That is any values it is true in this equation. That is why this equation is called an identity. Now, what is by trigonometric identity? An equation involved trigonometric ratios of an angle is called a trigonometric identity if it is true for all the values of the angles involved. All the values of the angles involved, then it is called a trigonometric identity. That is, here it is in case of an identity, simply if you are telling an identity means in variables will be there. Here variables a and b are the variables here. Any value we can substitute in place of a and b. So that is true. Then here it is variables. That is when it is true for an equation is called an identity when it is true for all values of the variables involved. In case of trigonometric identity, an equation consists of trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angles involved. All values of the angles involved. That is called trigonometric identities. Mainly 3 trigonometric identities are there. From there we can derive 6 more trigonometric identities. Mainly 3 you have to study. Then after that remaining we can derive it from that 3 trigonometric identities. So now we are going to study that 3 trigonometric identities. For that we have to draw a right angled triangle. A right angled at B. A, B, C. Angle B is equal to 90 degree. Angle B is 90 degree. And we are considering angle A as theta. Angle A as theta. Then which one is, if we are considering angle A as theta, which one is the opposite side? Opposite side is BC and adjacent side is AB. Then hypotenuse AC is the hypotenuse. We know that it is a right angled triangle. Then in this right angled triangle, if we use Pythagoras theorem, what is Pythagoras theorem? Hypotenuse square is equal to perpendicular square plus base square. And if we write it opposite, then what will come answer? AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Perpendicular square plus base square is equal to, we can write a hypotenuse square. Now, to get the first trigonometric identity, we have to divide this equation by AC square. Both sides of the equation by AC square. Then we will get AB square plus BC square divided by AC square is equal to AC square divided by AC square. Then AB square plus BC square divided by AC square, we can split it into 2. AB square divided by AC square plus BC square divided by AC square is equal to AC square divided by AC square. What is the answer? 1. Same times we are dividing. So answer will be 1. Now AB square divided by AC square. AB divided by AC, the whole square will come. A square divided by B square is equal to A divided by B, the whole square. In the squares and square root we have studied a formula. A square divided by B square is equal to A divided by B, the whole square, plus BC divided by AC. BC divided by AC, the whole square is equal to 1. Now, AB divided by AC, that is a trigonometric ratio. Find out it from here. Which trigonometric ratio is that? AB is the adjacent side, AC is the hypotenuse. So, adjacent side divided by hypotenuse. Which ratio is that? That is cos theta. Cos theta. Here square is there, so we will write cos square theta. AB by AC is cos theta. AB by AC square cos square theta, plus BC by AC. BC by AC. That is opposite side divided by hypotenuse. Opposite side divided by hypotenuse. So which ratio is that? That is sine. And BC by AC square is there, so we will write sine square theta is equal to 1. So this cos square theta plus sine square theta is equal to 1. That identity we can write this way. We used to write like this: sine square theta plus cos square theta is equal to 1. Sine square theta plus cos square theta is equal to 1. That is the first identity. Sine square theta plus cos square theta is equal to 1. Sine square theta plus cos square theta is equal to 1. That is the first trigonometric identity. So just remember that formula, that much only. This one just I have explained that how it will come. Then sine square theta plus cos square theta is equal to 1. It is a trigonometric identity, and any value you substitute in place of theta, here both sides will get answer 1. Any value you substitute, any angle, that is in place of theta, any angle you substitute, both sides will get equal. That is why it is called a trigonometric identity. It involves trigonometric ratios, and it is true for all the values of the angles involved. Angles involved is theta here. Any value you substitute in place of theta, both sides will get equal. That is why it is called a trigonometric identity. Now let's see second trigonometric identity. That is, to get the second trigonometric identity, we have to divide this equation both sides by AB square. AB square plus BC square by AB square is equal to AC square divided by AB square. Same formula only, that is this one is Pythagoras theorem we use, and both sides we have divided by AB square. First, to get the first trigonometric identity, we have divided both sides by AC square. Now to get the second trigonometric identity, we are dividing both sides by AB square. Now split it. AB plus BC, the whole square is AB square plus BC square divided by AB square is equal to AB square divided by AB square plus BC square divided by AB square we can write. That is equal to AC square divided by AB square. AC square divided by AB square. AB square by AB square. AB square divided by AB square. What is answer? 1. Dividing same terms, so answer will be 1. BC square by AB square. BC divided by AB, the whole square is equal to AC square divided by AB square. AC divided by AB, the whole square. Then that is equal to 1 plus BC by AB, the whole square. Find out the trigonometric ratio of BC by AB. BC is the opposite side. AB is the adjacent side. Opposite side divided by adjacent side. Which ratio is that? Opposite side divided by adjacent side is tan theta. So here it will come tan square theta is equal to AC by AB. AC divided by AB. Hypotenuse divided by adjacent side. Hypotenuse divided by adjacent side is sec theta. So AC by AB square, it will come sec square theta. That is the second identity. But this second identity we used to write like this: sec square theta is equal to 1 plus tan square theta. Sec square theta is equal to 1 plus tan square theta. 1 plus tan square theta is equal to 6 square theta we got here. That we are writing just opposite, that much only. So that is the second trigonometric identity. The second one is 6 square theta is equal to 1 plus tan square theta. 6 square theta is equal to 1 plus tan square theta. Now we will see the third trigonometric identity. To get the first trigonometric identity, we have divided this equation by AC square. Then we got sin square theta plus cos square theta is equal to 1. To get the second trigonometric identity, we have divided both sides by AB square. Then we got 6 square theta is equal to 1 plus tan square theta. To get the third trigonometric identity, we have to divide both sides of this equation by BC square. First one we have divided by AC square, second one AB square, third one BC square. Now split it. AB square divided by BC square is plus BC square divided by BC square is equal to AC square divided by BC square. Then that is equal to AB square by BC square. That we can write AB divided by BC the whole square plus BC square divided by BC square. BC square divided by BC square is equal to 1 is equal to AC square divided by BC square. AC divided by BC the whole square. Now find out AB by BC. AB divided by BC. Adjacent side divided by opposite side. That is cot theta. So here it will come cot square theta plus 1 is equal to AC by BC. AC divided by BC. Hypotenuse divided by opposite. Hypotenuse divided by opposite is cosec square theta. This formula also we will write just opposite only, that is cosec square theta is equal to cot square theta plus 1 or 1 plus cot square theta, both it is same only, so we will write here 1 plus cot square theta. Cosec square theta is equal to 1 plus cot square theta. That is the third equation. Third trigonometric identity is cosec square theta is equal to 1 plus cot square theta. Cosec square theta is equal to 1 plus cot square theta. So these are the main three trigonometric identities. From here we are going to derive 6 more equations. From the first equation we can derive 2 more. That is sin square theta plus cos square theta is equal to 1. Therefore sin square theta is equal to what is the answer? Right hand side 1 is there, that you have to write first. Plus cos square theta transposing to right side, it will become minus cos square theta. That is the second equation. Sin square theta is equal to 1 minus cos square theta. Now from this first equation, sin square theta you transpose into right side. Then what will remain here? Cos square theta. Cos square theta is equal to right hand side 1 is there, plus sin square theta transposing to right side minus sin square theta. That is the third equation. Now next one. From this second trigonometric identity, we can derive 2 more identities. That is sec square theta is equal to 1 plus tan square theta. 1 we will transpose into left side. Then we will get sec square theta minus 1 is equal to what will remain there? Tan square theta. Now to get the next equation, tan square theta we will transpose into left side. Left side what is here? Sec square theta is there. Sec square theta plus tan square theta transposing to left side minus tan square theta is equal to right hand side what will be there? 1. So sec square theta minus tan square theta is equal to 1. Now from this third trigonometric identity again we can derive 2 more. This is the same way only. Here how we got the second one? 1 we transpose it into left side, and the tan square theta we transpose it into left side to get the third equation. That same process we will do here also. That is, to get the next equation, 1 we have to transpose into left side, that is cosec square theta minus 1 is equal to plus 1 transpose into left side minus 1 is equal to remaining what is here? Cot square theta. Cot square theta. Now to get the next equation, plus cot square theta we have to transpose into left side. Cosec square theta is there. Cosec square theta plus cot square theta transposing to left side minus cot square theta is equal to right hand side what is here? 1. So these are the 9 trigonometric identities. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mainly you have to study these 3 trigonometric ratios. After that you derive it from there. Not at all by hearting these formulas. First these 3 formulas you have to remember. From there derive that remaining formulas. Then easily you can remember that formulas, that much only there. Then these are the 9 trigonometric identities. Now we are going to use these 9 trigonometric identities in the next exercise. So let's start next exercise. Exercise 8.4, question number 1. Express the trigonometric ratios sin A, sec and tan A in terms of cot A. We have to express sin A, sec and tan A in terms of cot A. In terms of cot A we have to represent. That means sin A is equal to, we have to get an answer. In the answer it should be, there should be cot A. That is, only cot A should be there. So that is the question. Express the trigonometric ratio sin A, sec and tan A in terms of cot A. So first sin A we can express in terms of cot A. First we will write sin A is equal to 1 divided by cosec A we can write. Sin A is equal to 1 divided by cosec A. Cosec theta and sin theta are the reciprocal ratios. So sin A is equal to 1 divided by cosec A. That is equal to 1 divided by cosec A is equal to, here there is a formula, cosec square theta is equal to 1 plus cot square theta. Cosec square A is equal to, we can write 1 plus cot square A. Then cosec A is equal to, what will come answer? Cosec A is equal to square transposing to next side, it will become square root of 1 plus cot square A. 1 plus cot square A. So this one you have to write in bracket. Cosec square A is equal to 1 plus cot square A. Cosec A is equal to square transposing to next side, it will become square root of 1 plus cot square A. So in place of cosec A, what we can write? Square root of 1 plus cot square A. 1 plus cot square A. Now we got the answer. Sin A we have expressed in terms of cot A. In the answer you see only cot A is there, no other trigonometric ratios. So this one is the answer. Sin A is equal to, we can write 1 by cosec A. Cosec square A is equal to 1 plus cot square A. Cosec A is equal to square root of 1 plus cot square A. So that we are writing in place of cosec A. Cosec A is equal to square root of 1 plus cot square A. So sin A is equal to, what is answer? 1 divided by square root of 1 plus cot square A. So now we have expressed sin A in terms of cot A. Now second one, sec. Second one is sec. Sec also we have to express in terms of cot A. Sec also we have to express in terms of cot A. Sec is equal to, how can we write that? Sec square theta is equal to 1 plus tan square theta. Sec square theta is equal to, here you have to write in bracket, sec square A is equal to 1 plus tan square A we can write. Then sec A is equal to, what will get answer? Sec A is equal to square root of 1 plus tan square A. Square transposing to next side. Square transposing to next side, it will become square root of 1 plus tan square A. So in place of sec A, what we can write? Square root of 1 plus tan square A. Square root of 1 plus tan square A. That is equal to square root of 1 plus tan square A. Tan A is equal to, what is answer? Tan A is equal to 1 divided by cot A. There is a formula. We have studied the formula. Tan A and cot A are the reciprocal ratios. So tan A is equal to 1 by cot A. Then tan square A is equal to, what will get answer? Tan square A is equal to 1 divided by cot square A. 1 divided by cot square A. So in place of tan square A we can write 1 divided by cot square A. 1 divided by cot square A. That is equal to square root of, we have to take LCM there. Square root of, what is LCM? Cot square A LCM. Cot square A LCM. Numerator, first rational number into LCM. 1 into cot square A, it will come cot square A plus 1 by cot square A into cot square A. Cot square A cancel, it will become 1. Now that is equal to square root split in the numerator and denominator. Square root of cot square A plus 1. That we can write 1 plus cot square A also. 1 plus cot square A divided by square root of cot square A. Square root of cot square A. That is equal to square root of 1 plus cot square A divided by square root square we can cancel here. What is answer? Cot A. Square root of 1 plus cot square A divided by cot A. That is sec is equal to, we got answer, square root of 1 plus cot square A divided by cot A. That means we have expressed sec in terms of cot A. Now third one is tan A. How can we represent that? Third one, you have to write below that, the number 3. Tan A is equal to, directly we can substitute that. Tan A is equal to, what is answer? 1 divided by cot A. 1 divided by cot A. That much only answer. Tan A is equal to 1 divided by cot A. Tan A we have expressed in terms of cot A, that is 1 divided by cot A. That is the answer. No need of writing these all the formulas. Then just from there I took that formulas here, that is why I wrote there. So this one you have to write inside the bracket. These formulas you have to write, and these are the main answer. Now let's see question number 2. Write all the other trigonometry ratios of angle A in terms of sec. Write all the other trigonometric ratios of angle A in terms of sec. That means sin theta, cos theta, tan theta, cosec theta and cot theta we have to express in terms of sec. Then first one is, number 1 is sin A. Sin A we have to express in terms of sec. How can we express in terms of sec? We know that formula sin square A is equal to, what is the formula? Sin square A is equal to 1 minus cos square A. 1 minus cos square A. Then sin A is equal to what will become? Sin A is equal to square transposing to next side, it will become square root of 1 minus cos square A. That we are going to write here in place of sin A, square root of 1 minus cos square A. That is equal to square root of 1 minus cos square A. Cos A is equal to, you know that formula, cos A is equal to 1 divided by sec A. Therefore, cos square A is equal to what will come answer? 1 divided by 6 square A. 1 divided by 6 square A. So in place of cos square A we have to write 1 divided by 6 square A. After that we have to take LCM here. That is equal to square root of, what is LCM? 6 square A LCM. Then numerator 1 into 6 square A, it will become 6 square A minus 1 by 6 square A into 6 square A. Second Roche number into LCM. Then 6 square A we can cancel. It will become 1. Now split the square root in the numerator and denominator. Square root of 6 square A minus 1 divided by square root of 6 square A. That is equal to square root of 6 square A minus 1 divided by square we can cancel, that is sec A. So we have expressed sin A in terms of sec A. Only in the answer sec A only. Square root of 6 square A minus 1 divided by sec A. Now second one, number 2. Number 2 is cos A. Cos A we have to express in terms of sec A. How can we express that? Directly we can write 1 divided by sec A. Cos A is equal to 1 by sec A. That much only. Cos A is equal to 1 by sec A. Now number 3. Number 3 is tan A. Tan A is equal to, how can we represent that? Tan A is equal to, here we can represent that. Tan square theta is equal to 6 square theta minus 1. Tan square theta is equal to 6 square theta minus 1. So tan theta is equal to, it will come square root of 6 square A minus 1. 6 square A minus 1. Tan A is equal to square root of 6 square A minus 1. Then in bracket you have to write the reason, that is tan square A is equal to 6 square A minus 1. 6 square A minus 1. This one is the formula. Tan square theta is equal to 6 square theta minus 1. So tan square A is equal to, we can write 6 square A minus 1. 6 square A minus 1. Therefore tan A is equal to what is the answer? Square root of 6 square A minus 1. 6 square A minus 1. That you have to write in bracket in this answer. Third one. Now number 4. Number 4 is, first sin A we have expressed in terms of sec. Cos A we have expressed in terms of sec. Third one, tan A we have expressed in terms of sec. Now next one is cosec. Cosec is the reciprocal of sin A. Cosec we can write direct 1 by sin A. Number 4, cosec A. Cosec A is equal to, what is the answer? 1 divided by sin A. 1 divided by sin A. That is equal to 1 divided by sin A. Already we got answer here. That is square root of 6 square A minus 1 divided by sec A. The square root of 6 square A minus 1. Square root of 6 square A minus 1 divided by sec A. Then that is equal to numerator into reciprocal of the denominator, that is 1 into sec A divided by square root of 6 square A minus 1. That is equal to 1 into sec A, it will come sec A divided by square root of 6 square A minus 1. That is the answer. So cosec A we have expressed in terms of sec A. Now next one is sec A. Sec A, here it is given, write all other trigonometric ratios. So sec A is sec A only. Now last one, which one? That is cot A. Cot A is equal to, how can we express that? Cot A is equal to 1 by tan A we can write. That is equal to 1 divided by, in place of tan A we will write this one. That much only answer. That is cot A. Number 5. Cot A is equal to, what is the formula? 1 divided by tan A. That is equal to 1 divided by, tan A already got the value here, square root of 6 square A minus 1. So 1 divided by square root of 6 square A minus 1. That is the answer. So 5 trigonometric ratios we have expressed in terms of sec A. Write all other trigonometric ratios of angle A in terms of sec A. So first sin A we have expressed in terms of sec A. Here we got the answer. Number 2, cos A we have expressed in terms of sec A. Tan A we have expressed in terms of sec A. Next cosec A we have expressed in terms of sec A. This one is the answer. After that cot A also we have expressed in terms of sec A. So that is the answer. Now remaining questions we will do in the next video. Thank you so much.